Hello my dear students, welcome back. This is session 2 on preparation strategy and importance questions related to SSC JEE electrical paper. Okay, so yes, day before yesterday again 7 p.m. to 8 p.m. that is on 10th May we discussed the preparation strategy, because to start first understand the pattern, the postings, what sort of paper and what level to prepare, and guidelines I gave including syllabus and marks division. Now this is continuation to that, it is part 2. Yes, we will be concentrating more on important question analysis and analysis to each chapter. That is on electric circuits or networks. And myself, yes, B.S. Krishna Varma, faculty in ACE Academy since 2009. Yes, this is session 2 on important questions. And again I want to highlight this, everybody, those who registered our online app, and also those who are writing this SSC JEE, there is a mock test, yes, on 26th May, and it is fee only 100 rupees, okay, it is only 100 rupees, please register. It is not about 100 rupees, it is about, you will know the ranking in India, that is very essential here. Now as I told in the last class, we did discuss all these points and we are into this 8th point, okay, yes. Now let us talk about this question papers and pattern of questions. As I classified the entire syllabus of SSC JEE into 10 chapters, we will group it separately and study. Now this is group 1. Now the group 1, I am going to combine chapter 1 and chapter 2. Of course, chapter 1 is mostly about fundamentals, which includes notations, unit symbols, basic circuit laws, example. And that continues to DC circuit analysis, because in ideal DC, resistor is the fundamental element, as inductor in steady state acts as short circuit and capacitor in steady state acts as open circuit. So this is like module 1 I am combining together in this discussion. So here sir, first of all, in competitive exam there is nothing like important or unimportant. But the standard of the questions that we are getting, we will discuss, everything is equal and important. Because in competitive exam he can pick up from anywhere, okay. This is not like your normal exams in degree or diploma or BTech, because you have a choice, you can leave some part of the syllabus. But it is not about that getting 70 or 80%, it is beating about 99.99% of the competition. So everything is equal and important, but let us see what exact standard, and in the process of teaching these bits, I will tell you and revise the entire concept related to these 2 chapters, okay. Chalo, this is the first question on reduction technique. See this question, what is R equivalent, he asked. Now you are confused with the type of interconnection, so do node shifting technique. So he want R equivalent and there are 3 resistors and there are wires connected like this. Looking, everyone gets confused, what is this connection? So let us do node shifting technique. Let this be node A and let this be node B. Now this is same node A, same wire connected, so this is also node A, same wire connected until this is also node B only. So finally there are only 2 nodes, okay. This is entire node A, this is entire node B. So I will do node shifting. So I will write here A and B. Now there is a 3 ohm between AB, okay, 3 ohm between AB, another 3 ohm between AB, yes, and another 3 ohm between AB, yes. So 3 parallel, total resistance is only 1 ohm. So it looks confusing, but after doing node shifting technique, yes. So remember, there are so many such questions where you have to reduce and simplify, reduction techniques. So if the circuit looks confusing, do node shifting. So what is node shifting? Yes, place the nodes and shift it. Finally, it looks confusing, but actually all are parallel. 3 parallel is 1 by R is 1 by 3 plus 1 by 3 plus 1 by 3. 1 by R is 1. R is also 1. Now here you see, very interesting. What is R total? What is R total seen from there? But this time you see these are practical sources. Why they are practical? Because they have internal resistance. Okay, they have internal resistance. This is also practical source, internal resistance. So we should include that resistance and argue. Chalo, what I will do? 2 ampere 4 kilo means, yes, 2 ampere 4 kilo means, yes, what is the meaning? Here it is 4 kilo ohm coming here, okay, because practical current source has large resistance in parallel. So 2 ampere 4 kilo means I will remove from here and I will write here. And what about practical voltage source? Practical voltage source has small resistance in series. So I will remove that and write here, this is also 2 ohms. So now I included the resistance of practical sources. Because question is about resistance, we should include the resistance of sources also. If they were ideal, simple. If ideal current source, open it. Ideal voltage source, short it. But they are practical. So we should include their internal resistance. So practical current source has large resistance in parallel and practical voltage source has small resistance is. Now remove the ideal part. So now current source is open, voltage source is short. So if you look from there, 5 plus 2, 7 plus, 5 plus 2, 7 plus. Now see, 3 kilo in parallel to 4 plus 2, 6 kilo. 3 kilo in parallel to 6 kilo. Because this is 3 kilo, these two become series, 2 plus 4, 6 kilo. But 6 kilo in parallel to 3 kilo is nothing but 18 by 9, 2 kilo. 2 kilo plus 7, 2007 ohms. 2 kilo plus 7 is 2007 ohms. Okay, that is the answer. Then, here another interesting problem I want to expose with the dependent source. Yes, in SSC JEE there are problems with the dependent source, so I want to give this unique model. Here I want again resistance between AB, but there is a dependent source. Dependent sources will have internal sub-circuit resistance and we should include them in analysis. Okay, if it is an ideal source, voltage source short, ideal current source, but it is a dependent source, it has internal sub-circuit resistance. So what I will do, I should include it and write. Chalo, now in that regard, I will apply Ohm's law. Because we should include the internal resistance and reduction not possible, what I will do, I will apply Ohm's law. So what I will do, sir, let me inject a current of 1 ampere, okay, and find voltage across it. Why I take 1 ampere? Because easy calculation. You can take any current because ratio of V by I is R always. You can take 1 ampere, 100 ampere, anything, your lucky number also. But better take 1 ampere because easy calculation. In such exams, don't take risk. Chalo. So I injected 1 ampere. I need to find voltage. Vx by 1 will be R, Ohm's law. But because 1 ampere is going through all the elements in series, this is 1 1s are 1 volt, this is 1 2s are 2 volts, and this is 1 3s are 3 volt. Chalo, I am writing a KVL because R is Vx by 1. To find Vx, I am writing a KVL. Chalo, minus Vx plus 1 ampere in 1, 1 volt, 1 ampere into 2, 2 volt, plus this is Vx by 2, and this is 1 ampere into 3, 3 volt equal to 0. So if you observe, Vx by 2 is 6, Vx is 12 volt. Chalo, if Vx is 12 volt, then what is RAB? RAB is Vx by 1, which is 12 ohms. So this is 12 ohms. Very simple. Okay, 12 ohms. So the total resistance, including the sub-circuit resistance of dependent source, is 12 ohms. Now let us go further. What is the effective resistance? Now this is a very interesting term. Okay, effective resistance. So this bit also came, so I want to highlight. Effective resistance is the resistance offered by the network to the source under working condition. What is the effective resistance seen by the voltage source? So effective resistance is the resistance offered by the network to the source under working condition. Network to the source under working condition. So now we should not remove anything. If it is Thevenin's resistance or open circuit resistance, I will remove the unnecessary part. But here it is effective resistance. So that R effective will be, yes, R effective is the resistance offered by the network to the source under working condition. Chalo, now we cannot reduce, so I will apply Ohm's law. This is 18 by I total. This is 18 by I total. Okay, so this is 18 by 3, 6, 18 by 6, 3. Now if you apply KCL, 9 plus 3 plus 6, it is also 18. So it is 18 by 18 without reduction, which is 1 ohm, 1 ohm. Okay, 18 by 3, 18 by 6, 9. So 9 plus 9, 18, 18 by 18 is 1 ohm. Okay? Now look at this, everybody. I want voltage Vx. Very interesting, I want voltage Vx. This is an SSC JEE bit. Now to write voltage Vx, I will write a KVL. But to write a KVL here or here, I need the remaining branch voltages. These voltages I know, but these voltages I don't know. So what I will do, first I will do mesh analysis to find the voltage and then KVL. Chalo, let me take mesh current clockwise I. So what is the mesh equation now? Chalo, mesh equation is also KVL. Minus 5 plus 6I plus 10 plus 5I plus 50 is 0. Okay? Minus 5, 6I plus 10, 5I plus 50. So 11I is minus, you see, 55. So I is minus 5 ampere. Now minus 5 ampere is not wrong. Minus 5 says that actual current is going anti-clock. I took clock, but I got minus, means actual current is going anti-clock. Now transform this mesh current into branch current. Because actual current is going anti-clock 5. Actual current is going anti-clock 5. So this branch current is also 5. This is also 5. So now when 5 goes through 5, 5 5s are 25 volt. This is 5 6 are 30 volt. So now to find this unknown voltage, I will write a KVL here. Chalo, this is minus 5, minus 30, plus 10, plus Vx is 0. This is the KVL I am writing. Mesh is also KVL, but this is the KVL to find unknown voltage. So minus 5, minus 30, plus 10, plus Vx. So Vx is plus 35 minus 10 plus 25 volt. 25 volt is the answer. Okay, na? 25 volts. So now in this regard, everybody look here. Everybody look here. I need to find voltage V0. So I look here, I need to find voltage V0. Very interesting bit. Everybody watch this. I need to find voltage V0. V0 is a voltage here. Very interesting. He gave some interesting options also. Okay, but be careful. Now, no doubt there is a current source in series to all the elements, current is always constant. There is a current source in series to all the elements, current is always constant. When 2 amperes is going to 3, this is 2 3s are 6 volt. Okay, when 2 amperes is going to 3, 2 3s are 6 volts. Now, this is 6 plus this is 4 until here it is 10 volt. Because KVL satisfied now, 6 plus 4, 10. Okay, 6 plus 4, 10, no doubt. So, this is 6, this is 4, 10. But without knowing the voltage across current source, don't argue V0 is 10. Because there will be certainly some voltage across current source, which I don't know right now, because network is not exposed. So here data is insufficient, because 6 plus 4, 10 is up to here. But without knowing the voltage across current source, how can you say V0 is 10? We don't know. So data is insufficient. Yes, not possible to determine. Very interesting bit, na sir. Everyone, most of them who wrote exam that year, they told answer is 10. But 6 plus 4, 10 is up to here. But without knowing the voltage across current source, how can you say V0 is 10? Yes, not possible. Now another interesting bit, what is V0? Okay. Now what is V0? See, he gave voltage across 5 ohms is 10 volts. This voltage across 2 ohms is also 10 volts, but he is asking V0. Don't think this is parallel. It is a very cunning bit, na? If you feel it is parallel, who told they are parallel? This is different network, this is different network, internal connections we don't know. Those internal connections we don't know. But don't argue this parallel and say directly it is 10 volts. No, no, no. Because they are not parallel, sir, networks. If these are not networks, single node, then they are parallel, voltage would have been same. But this is not parallel. Then what I will do, apply KCL. See, this is 10 volts across 5. So this is 2 amperes now, because I is V by R. I is V by R and current enter positive in a sink. Here also 10 by 2, 5 amperes. Here also I is V by R, 10 by 2, 5, current enter positive. Now see, total 2 and 5 entering, how much should come out? 7 should come out. When 2 and 5 entering, incoming currents equal to outgoing currents, na? 2 and 5, 7 entering, 7 should come out. But 7 is going this way in a passive element, 7 3s are 21. So V0 is plus 21 volt. Answer is 21. Very interesting, na? So don't misunderstand it is parallel. Now see this another observation bit. Very, very interesting. Observe, sir. Read the question, everyone. If voltage element, see the meaning. If voltage element absorb power, then find current I. If voltage element absorb power, find current I. Now see, if this is absorbing, this is source or sink, this becomes sink. If this is absorbing, that becomes sink. If it is sink, current should enter positive, na? If it is a sink, current should enter positive terminal. That means out of 12, some current is entering. Because if this is absorbing, current should enter positive. So out of 12, some current is entering. Out of 12, if some current is entering, this should be less than 12. Less than 12, only one option. Less than 12, only one option. Okay? Yes, out of 12, something is entering. This should be less than 12. Less than 12 is only one option. 10. Yes, less than 12. So there is nothing to do here. Very interesting. Okay? 10. Because this cannot be. Because if it is a sink, current should enter. Out of 12, something gone means less than 12, only one option. Option based bit. Very famous in SSC JEE also. Find voltage Vx. See, find voltage Vx. Again, sir, simple bit. Be careful. Don't make it materialistic and start writing equations. They are very simple bits here. So, to find Vx, I will write KCL, KVL. See, there is a voltage dependent current source, but I want Vx. Now, this is Vx, this is 1 ohm. So, this is Vx ampere na, because I is V by R. I is V by R. So, this is Vx, 2Vx, total it become 3Vx. Okay? See, I is V by R. And current enter positive in a sink, this is 2Vx. So KCL, Vx, 2Vx, 3Vx. Then I will write a KVL. So if I write a KVL, minus 10 plus Vx plus 15Vx is 0. See, minus 10 plus Vx, I into R, 5 3s are 15Vx. So 16Vx is 10, Vx is 10 by 16, that is 5 by 8 volt. 5 by 8 volt. 10 by 16, na? 5 by 8 volt. Simple. See how simple it became KCL, KVL. Now look at this another SSCJ bit. See this question. A network has 12 branches and 5 nodes. Okay. then the number of independent loops. Independent loops. So to confuse you, he is using this term. Actually, loops are all possible closed paths, but independent loops are meshes only. Loops are all possible closed paths, but independent loops are meshes. So indirectly is asking meshes, but meshes are branches minus nodes plus 1. So your branches are 12, nodes 5 plus 1. So answer is how much? 8. Answer is 8. So independent loops are nothing but meshes. Meshes are 8. Okay, branches minus nodes plus 1. Now look at this. Find the value of G equivalent in the following circuit. What is G? R resistance, L inductance, C capacitance. G is conductance, reciprocal of resistance. Conductance is reciprocal of resistance, and that is why units are in Siemens or mho. You can write in Siemens or mho, which I told you in my app. Okay, chalo. Now you want, but conductances in series parallel formulas are reversed to resistor. Chalo. Now first of all, this 6 is in parallel to these two in series, but when these two are in series, it is ulta to resistor formula. Okay, so this will be this into this by sum, that is 20 into 5 by 25, 4 Siemens. Now 4 Siemens in parallel to 6 Siemens is nothing but 10 Siemens. Answer is 10 Siemens. Because series parallel formula of conductance is reciprocal to resistance. Then everybody, this is one of the very good bits. Okay, determine the currents X and Y in the given network. He is asking this current X and Y. And he gave so many things, reduction not possible. So be careful and quick and fast. Safe is nodal. See, what I will do is, I will take this as reference, or you write equations, and I will write one nodal equation V here. So now what is the nodal equation? This is nothing but V minus 12 by 2 plus, okay, V minus 8 by 1 plus V by 10 is 0. That is the fastest way, only one equation. KCL, V minus 12 by 2, because that is the reference, V minus 8 by 1, V by 10. If I take LCM 10, this is nothing but 5V minus 60 plus 10V minus 80 plus V equal to 0. So total 16V is equal to 140. So that implies V is 70 by 8 or 35 by 4. Chalo, V is 35 by 4. Now once V is 35 by 4, now see what is X? X become 12 minus V by 2. 12 minus V. But what is V? 35 by 4 by 2. So LCM you take, it becomes 8. 48 minus 35, yes, 13 by 8. So 13 by 8. But 13 by 8 X, two options are there. These two cannot be the options. There are two more options. So let us find Y also. But what is Y this direction? 8 minus V by 1. That is, Y is 8 minus V. But V is again 35 by 4 by 1. So if I take LCM 4, yes, this is 32 minus 35 minus 3 by 4. So Y is minus 3 by 4. Minus 3 by 4. So X is plus 13 by 8. Y is minus 3 by 4. So answer is A. These two are close bits. Be careful. Okay. Not that you cannot do anything, but safest and fastest only by one equation, I think, is nodal is faster. So in exam, be clever, sir. Not writing multiple equations and wasting time. Okay. Then see this. Determine the source voltage Vs. He is saying this is a source, some pseudo source. Okay, and is asking us to find Vs. Unknown voltage KVL. Chalo, happily write a KVL. If I start writing here KVL, or here I will start minus 10. See, minus 10 plus 20 plus 5 minus 30 plus, yeah, it is not plus, it is minus. Okay, let me write minus Vs is 0. So from that Vs will be how much now? Okay, see, minus 10 plus 20 plus 5 minus 30 minus Vs is 0. So if you take Vs that side, Vs is, this is nothing but minus 40 plus 25. Yes or no? Minus 40 plus 25, minus 15. Okay, so yeah. Okay, so if you see minus 10 plus 20 plus 5 minus 30 plus minus Vs. So Vs, if you take that, this is minus 40 plus 25. Okay, that you be careful here. Yes. So yes, data you see there may not be accurate, but this is the answer because this is minus Vs we wrote. Okay, that is a KVL clockwise I am writing. Then you see here, this is very standard. If R1 is the resistance of conductor at T1 and R0 is resistance at T0, temperature T0. Temperature means what? Yes, T0. Coefficient of resistance of T0 is alpha naught, the relation between these two quantities. So we know that practically resistance depends upon temperature. Practically resistance depends upon temperature. We say in LTI system, ideally by defining Ohm's law, assume temperature constant. It is an assumption, but actually material depends upon resistance. Resistance and resistance also depends upon temperature. And in metals, the temperature coefficient of resistance is positive, but in semiconductors it is negative. But he is telling R1 is the resistance of conductor at T1 and R2 is at T0, R0, and coefficient of resistance at T0 is, so he gave temperature coefficient of resistance at T0. So what is the formula we know? Chalo, this R1 is R0 into 1 plus alpha naught into T1 minus T0. If I expand this, R1 will be R0 plus alpha naught T1 minus T0 into R0. See this, okay? If you observe now, which is the giving the correct answer? Yes, it is option B. Yes or no? Yes, it is matching with option B. Be careful. Because here temperature coefficient of resistance is given at R0, which is T0, okay? That is the thing. Okay, that is the answer. So from this, by the given data, you can find temperature of that material at any temperature, or resistance of that material at any temperature. Now see, the resistor is rated for, now see this, the resistor is rated for 2.5 kilo 1 watt. Now 1 watt means it is electronic resistor printed circuit board, quarter watt, half watt, 1 watt. So the power rating is 1 watt and it is a 2.5 kilo. Determine the maximum and voltage current ratings. Chalo, first of all, we know designed resistance. Designed resistance is V rated square by P rated. That is standard formula which I told you. Design resistance is V rated square by P rated. Now from that we can find, because power rating is given and resistance is given, we can find the voltage rating. So V rated square is, okay, design resistance into power rating. Now power rating is how much? 2.5 kilo, that means 2500 into 1 watt, 1 watt. So V will be root of this. So V will be root of this. Okay, that is nothing but 50 volt, 50 volt. So rated voltage is 50 volts. Rated voltage is 50 volts. There are two options. These two cannot be the options. But from Ohm's law, what is I rated? I rated is simply P rated by V rated. P rated how much? 2500 by V rated is how much? 50. So it is how much? Yes, P rated, because P is VI, P rated by V rated, that is 2500. Okay, sorry, power rated is only 1 watt. Let me correct it. 1 by 50. 1 by 50 means 20 milliampere. So voltage rating is 50, okay, and 20 milliampere. Option D. Option D. This is the meaning. That means a 2.5 kilo 1 watt resistor can handle maximum of this much voltage and this much current. If you exceed the voltage, correspondingly current can decrease, or if you exceed the current, corresponding voltage. But together, this is the maximum rating. Okay, that is what he asked. Then what is V0? See this question, interesting question. Is asking V0 voltage across 4 ohms. Okay, V0 voltage across 4 ohms. Now in that regard, if you observe, everybody, I will apply simple KCL and KVL. See, this is 3, this is I0, this is 0.50. Now if you apply KCL here, this is 3, this is I0. So this current is 3 minus I0, na? This is 3 minus I0. But this 3 minus I0 should be minus of this. So this 3 minus I0 is minus of I0 by 2. Okay. So I0 by 2 is 3. That implies I0 is 6 amperes. Now once I0 is 6 amperes, what is V0? V0 is 4 I0. That is 6 4s are 24 volts. Simple. 24 volts. Option C. Simple KCL, sir. Don't do big equation. See, out of 3 I0 went, so this is 3 minus I0. But this direction is opposite to this. So 3 minus I0 should be minus of 0.5 I0. So if I equate I0, I got. Now V0 is IR, I0 into 4, 6 4s are 24 volts. Now total charge Q of T in coulombs that enters the terminal element is this. See, he said the total charge in coulombs that enter terminal of an element is this. Before 0 it was 0, from 0 to 2 seconds it is 2t, and after 2 seconds it is this function. Determine the current at 5 seconds. Now we know current is rate of flow of charge. Yes or no? Yes, we know current is rate of flow of charge. So I is dq by dt. But because he is asking current at 5th second, so this function we have to do. Okay? Okay. So I is dq by dt. So first of all, let us see this I is differentiation of this dq by dt. But this function, if you write clearly, this is 3 plus e power minus 2t plus 4. Okay? E power minus 2t plus 4. Now differentiate. I is dq by dt, differentiation of constant 0. This is nothing but e power minus 2t plus 4 into minus 2. So I is minus 2 e power minus 2t plus 4. But he is asking current at 5th second. Now substitute that. At 5th second, this becomes minus 2 e power minus 10 plus 4. So it is minus 2 e power minus 6 amperes. Minus 2 e power minus 6 amperes is C. C, that is only current is rate of flow of charge. Okay, that is the meaning. Okay, very simple. Be careful. Okay, then chalo, the first two chapters I covered one reduction. Okay, I covered on rating. Yes or no? I covered on KVL, KCL, Ohm's law, such things. That is the standard which comes. Now just chapter 3 is unique, which is basics of time variance. Especially in this chapter we introduced inductor and capacitor. In all the previous chapter, what we assumed that it is an ideal DC, di by dt is 0, dv by dt is 0. Inductor in steady state was short, capacitor in steady state was open, only resistive networks. But this chapter we are going to classify towards basics of time variance, and when such time varying signals are given, then inductors, capacitors do respond. So this is separate module which I taught you in my app, and based on that I will give you some previous paper questions to understand the limit. Now see this question. The voltage current plot in a passive component is shown below, then determine the component. The voltage current plot in a passive component is shown below, determine the component. This is voltage, that is current. Now first of all we have three fundamental passive components. One is V equal to IR, then V is 1 by C integral I dt, and V is L di by dt. Can this be resistance first of all? No. We know resistance is a homogeneous proportional component. Yes or no? Resistance is a homogeneous proportional component. This cannot be resistance. The reason this cannot be resistance because if pulse step voltage or pulse voltage is given, current also should be pulse. If current is ramp, then voltage also should be ramp. That homogeneity is missing, so this cannot be resistor. This cannot be resistor. Then what about capacitor? V is 1 by C integral I dt. V is 1 by C. 0 to 2 it is a positive ramp. 0 to 2 it is a positive ramp. Okay? Then V is 1 by C integral. So integration of ramp is parabolic. V is 1 by C integral. Integration of ramp should be parabolic. Okay? But see, voltage is step. So it cannot be capacitor because in capacitor V is 1 by C integral I dt. Integral of ramp should be parabolic. So this is also not possible. Then the third one, V is L di by dt. Yes or no? V is L di by dt. Okay? Chalo. Here 0 to 2 second, if it is a ramp, differentiation of ramp is step. Okay? So this matches. And moreover, after 2 seconds, current is constant. Differentiation of constant is 0. 0. So this is perfectly matching what? Yes, inductor. So yes, the voltage current plot in a passive component, then determine the component. What is the component? Inductor. It is inductor. Now, what is the value of inductor also we can tell. Because we know in inductor V is L di by dt. The same formula I will write it as V equal to L I2 minus I1 by T2 minus T1. These are linear relations. Same formula I wrote like this. Now how much is the voltage induced in that element? 2 volts. So this is 2 volts. Okay, L value I don't know, we have to find. Now I2 minus I1. See, it is raised ramp na? I2 minus I1 is 2 minus 0 by T2 minus T1. This is also 2 minus 0. Okay, so if you remove this is 1, L is 2 Henry. L is 2 Henry. Yes, inductor is 2 Henry. Okay, yes, inductor is 2 Henry. Okay, see, a simple problem, but explore the VI relations in these passive elements. It has to be an inductor. Now the voltage Vs of t is 40 t volts and IL of 0 is 5 amperes. See, this voltage is 40 t volts and IL of 0 is how much? 5 amperes. Then find the total current. Now this is demonstration of Kirchhoff current law. Okay, so this total current is IR plus IL. Yes or no? But this is a ramp voltage given and is asking to find total current here at t equal to 2. So this I of t is IR of t. But what is IR of t? Vs of t by R. Okay, and IL of t. But IL of t is integral V dt. And moreover, initial condition given na. So I will write this as IL of 0 plus 1 by L integral Vs of t dt. So this is the accurate way. Because initial condition given, take it. If it is not there, it would have been 0. So now what is Vs of t? It is 40 t na. So 40 t by R is how much here? R is 10. 10. IL of 0 is 5. 1 by L. L is also 5 Henry. Integral nothing but 0 to t. Yes, 0 to t. Vs is 40 t dt. So if you observe everyone, this is 4t plus 5 plus 4t square is the current function. But is asking current at t equal to 2 na, substitute. That is 4 into 2 plus 5 plus 4 into 2 square. This is nothing but 29 amperes. Yes or no? 29 amperes. Okay, 24 plus 5, 29 amperes. Because it is a sum of ramp current and parabolic current. When a ramp voltage is given to resistor, current is also ramp. But when ramp voltage is given to inductor, current is parabolic. Okay, that is the meaning there. Then sir, see this question. For the network, convert star to delta. For the network, convert star to delta. Convert star to delta. Chalo, let this be some Cx. Let this be some Cx. Okay, I will convert star to delta. But remember, star delta, delta star conversion in capacitor is similar to resistor, but reciprocate every time including the left hand side. So this 1 by Cx is, okay, this plus this, but reciprocate 1 by 1 plus 1 by 2 plus this into this. That is 1 by 1 into 1 by 2 by opposite 1 by 3. So 1 by Cx is, this is 3 by 2 plus 3 by 2, 3. That implies Cx is 1 by 3 farad. This is Cx is 1 by 3. Then if suppose this is Cy, then do the same way, it will be 1 farad. Then if it is Cz, yes, this Cz will be 1 by 2 farad. You do it. So finally, if you convert this star to delta in capacitor, reciprocate every time including the left hand side. So this will be 1 by 3 farad, 1 farad and half farad. Okay, very interesting bit. But be careful, remember the resistor formula, but reciprocate including the left hand side. Then here you see this question now. If 4 10 millifarad capacitors are connected in parallel, net capacitance. In capacitance, add resultant, ulta to resistor. If 4 10 millifarad capacitors are in parallel, the net capacitance is 40 millifarad. Okay, 40, if it is micro, yeah, he should have given micro. See, question is given in milli, but he gave in micro. It is a print mistake in SSC JE. See, 4 10 milli capacitors connected in parallel. So, you add 10 plus 10, 40 millifarad. I think I will take this, though in option, he gave micro there in milli. It is a print mistake, but you take this. It has to be add 10 fours of 40. Then, the wave shape of current flowing through an inductor is this. Listen carefully. The wave shape of current flowing through an inductor is this. Okay? Yes. Then, the wave shape of voltage drop. Okay? Current is given. Okay? And is asking voltage drop. So, here, sir, yes, if this is the current, step current. Okay? If this is the current he gave, step current, then current flowing. Now, we want voltage, but V is L di by dt. Okay? So, actually, he gave a voltage. If it is a step voltage, I think differentiation of step will be what? Differentiation of step will be impulses. That is not there. Maybe, yes, this is the shape of voltage. Where this is not the case, this is the shape of voltage. But you give ramp voltage. Now, see, differentiation of ramp is step. So, V is L di by dt. Current is ramp. Then differentiation of ramp should be step. So, option should be D. So, based on the data, you have to write. Because V is L di. Because actually, this would be the case. This could not be the reason. Otherwise, if square current, impulse voltage should come. Impulse voltage, but impulse voltage, there is no such thing. So, I understood that the dotted line is the meaning, but this is how the printing came. Chalo, ramp voltage, but V is LDA, differentiation of ramp is step. Step is this. Okay. Then, a coil with certain number of turns has specified time constant. Listen carefully. A coil with certain number of turns has specific time constant. If number of turns are double, then the time. These are very famous bits, sir. Now, you know, a coil means it is a practical inductor. Coil means practical inductor. Practical inductor also will have resistance which decides the time constant. So, we know tau is L by R. Yes or no, tau is L by R. That is the time constant. Now, we said that if the number of turns in the coil are double. So, first of all, if the number of turns are double, inductance become 4 times because L is nu n square A by L. Inductance is proportional to square of turns. If number of turns are doubled, yes, if number of turns are doubled, inductance become 4 times. No doubt this become 4 times. But what about resistance? To get the double turns in the coil, I need double the length of the wire. Na? To get double turns in the coil, I need double the length of the wire. But if wire length is double, resistance also will double. So the new time constant, is 2L by R. It will double. So the new time constants become double. So interesting. If turns are doubled, inductance become 4 times, but resistance become 2 times. Overall time constant only double. Okay. So now let us see the next question. See this question, everybody. The purpose of choke coil in fluorescent tube is to ignite it, to develop high impulse voltage. Because you know V is L di by dt. Now to this choke coil there is a starter. When you suddenly interrupt the current through choke coil, like sudden change in current, delta T tends to 0, this become impulse voltage. So if delta T tends to 0, this become what voltage? Impulse voltage. So that huge impulse voltage will come across tubelet and turn on. So the purpose of choke coil in a fluorescent tube is to develop impulse voltage to ignite it. So increase voltage momentarily, increase voltage momentarily, and that will ignite the gas tube, because to ignite gas tube I need kilovolts, but normal voltage in our house is 230 RMS. So if you want to ignite gas tube, I need kilovolts. The choke is doing the business by developing large impulse voltage. If capacitors are charged by a square wave current, okay, if capacitors, then the voltage. But V is 1 by C integral IDT, again Ohm's law. See, he said capacitor is charged by a square wave current. Square wave, this current is square wave, this current is square wave. Integration of step is ramp. So if it is a square wave like this, then integration of positive is positive ramp, negative is negative ramp. So what current will come? Triangle. Simple basic, sir. See, V is 1 by C integral IDT. Current is square wave, positive, negative. If it is a square wave, positive ramp, positive step is positive ramp, negative step is negative ramp. So what will be the voltage? Triangle. Yes, triangular wave. See that basic triangular wave. Ohm's law only. Then the purpose, a prototype low pass filter, the series and shunt elements are dash. See, he said it is a prototype low pass filter. Okay. Now filter has a series and shunt element, and this is Vi and this is Vo. Now low pass filter should allow low frequencies. Low pass filter should allow low frequencies. That means at 0 frequency output should come, at infinite frequency output should be 0. At 0 frequency output should come infinite. But see which element will be considered as series and shunt. See, series and shunt. A prototype low pass filter, the series and shunt elements. See, this is called series element, this is shunt element. Options, let us see. He is saying one capacitive, one inductive, first option. Can this be correct? If you see, at 0 frequency capacitor is open, inductor is short. At 0 frequency capacitor is open. When capacitor is open, output is also open. So it is not allowing low frequency. So this is wrong combination. This is wrong combination. But if you say inductive capacitive, I think correct. See, if it is inductor and this is capacitor. Now at 0 frequency, low frequency, inductor short, capacitor open. Inductor short, capacitor open, full output will come. Full output will come. So this is matching. What about the rest of the options? Series combination of capacitor inductor. No. If it is a series combination of inductor and capacitor, you see for 0 frequency this is short but this is open, output is 0. Infinity frequency this is short, this is open, again output is 0. So this cannot be the case. And finally, resistor and inductor. How can this be resistor and inductor? See, if I say resistor inductor, at 0 frequency this is short, output is 0. So this also cannot be the case. So the answer is series component L, shunt component C, B. Just put them and think, sir, and vary the frequency. Low pass filter means allowing low frequencies like 0. High pass filter means allowing high frequencies. So for 0 frequency, low frequency, inductor short, yes, capacitor open. Inductor short, capacitor open means full voltage will come here. So it is allowing low pass. A 10 ohm resistor, 1 Henry inductor and 1 microfarad capacitor is connected in parallel. The combination is driven by a unit step current. The combination is driven by a unit step current under steady state, then the source current flows through dash. So in steady state, it is driven by unit step current. So let us say it is a unit step current U of t. But here it is, yes, 10 ohm resistor. Yes, let me correct, it is 10 ohm resistor. Okay? And then it is 1 Henry inductor, and also 1 microfarad capacitor. But in DC steady state, inductor short, capacitor open, na? Inductor is short. So this resistor is also short and this is open. So full current flows only through inductor. Yes, full current flows only through inductor because inductor is short. Full current flows through inductor. Okay, na? Then what will be the equivalent inductance for a circuit given below? See, sir, what is the equivalent inductance for circuit? He gave like this to confuse you, but I think this entire T network is shorted or not? Shorted. This entire T network is shorted, so it is only 40 milli. It is only 40 millihenry. Because this is short, sir. So you may see, sir, these two are parallel. Okay, you may do parallel, then series. But what is the use, sir? This is short circuit, na? Short circuit completely in parallel to passive elements are redundant. It is only 40 millihenry. Very interesting. Okay, now we will go to another set which I talked, that is the third module. So this module is about combination of, one is AC fundamentals, phasor, average RMS values of time varying, and solution methods and power factor. Okay, very interesting. AC steady state we call. Okay, this is the third module which I want to discuss and see the level of questions which are coming. Now the effective value of voltage given by this. Effective value means true value or RMS value. Effective value means RMS value. But he gave a function which is like a Fourier series. So effective will be, this is DC component 100 square, this fundamental 25 by root 2 square, and this is again yes 10 by root 2 square. Okay, if you observe, this is root of 10,000, okay, plus this is 625 by 2, okay, somewhere 625 by 2. So it is coming around 312 something, okay, 625 by 2 is 312.5 plus this is 100 by 2, 50. So if you observe, this is overall root 10,362.5. So it is very near to 100 only. It is very near to 100, which is 101.08. It cannot be 110. 110 means very large. 135, 100, slightly nearer to 100. Because around 10,000, near to 10,000 is 101.8. Like that you have to guess. Okay. Then the voltage and current in the device are shown. The power P indicated in watt. Now, you know in AC, power is VI cos phi. The phase angle will decide. So P is power indicated P, active power. VRMS, this is maximum na? VRMS, IRMS, cos of phase angle. Cos of phase angle is cos 30. Okay, so if you observe, this is 500, cos 30 is sin 60 root 3 by 2. So less than 500, yes, somewhere in 433. Less than 500, only one option. Okay, 500 into root 3 by 2. Okay, 1.70. So less than 500 is only one option, direct. Now determine the average and the effective values of this function given. Average and effective. Now average value, I told such chopped DC how to do. V average is this into x by y. X is on by total time period 0.3. So this is 20 by 3. 20 by 3 is 6.667 something. But VRMS, what is VRMS? 20 root 0.1 by 0.3 root. Okay, that if you see 20 in by, this is going to be root 3. Okay, 20 by root 3. So 20 by root 3, if I go with that, it is root of 400 by 3. 400 by 3 is 133.3, root 133.3. So one way average is 6.667 and RMS is root 133. So average is 6 point and average. So option C. Option C. 1000 cannot be and this is 6. Okay, that is also simple bits. Calculator also not necessary. Chalo, now look at this next question everybody. A current of 10 plus 10 sin t amperes is passed through a moving iron type ammeter. Moving iron type meter read what value? RMS value again. So RMS of this. So RMS is root of 10 square plus 10 by root 2 square. Okay, that is answer 10 by 10 by. So this is nothing but root, this is nothing but 100 plus 50, 150, root 150. Chalo, root 150 is this, option C. Simple bit. Okay, RMS of the signal is a combination of DC and AC. Now see this question, a current read by the ammeter in the circuit shown. So first of all, current read by the ammeter, but all are working means it is not DC sir, it is RMS AC signals. These are RMS of AC. But you know in AC circuits, phasor sum of component currents is total current, not algebraic sum. So don't say 1 plus 3 plus 5, it is 9 ampere. Don't ever attempt to write this because phasor sum. Now first of all in a parallel circuit I will take voltage as reference. Now with respect to voltage, which current is in phase? Resistor current. Resistor current is how much? 3 amperes. 3 amperes. What about inductor current? Inductor current is lagging by 1 ampere. Chalo, inductor current is lagging by 1 ampere. Lagging. Capacitor current is leading by 5 ampere. Leading by 5 ampere. So in a parallel system I will take voltage as reference. With respect to voltage, IR is in phase, that is 3. IL lag by 1. Okay, and IC lead by 5. Now phasor sum of this IR plus IC plus IL, IR plus IC plus IL. But IC and IL are unequal opposite forces. So this is 5, this is 1. So this resultant become 4. This is 4, this is 3. Okay, this is 4 and this is 3. Let me write. This is 4, this is 3. Resultant is 5 amperes. So answer is 5 amperes. Be careful. Okay, it is 5 amperes. The phase difference between voltage and current. Phase difference is asking sir. See, one is some voltage, sine and sine given, no confusion, same frequency, now see. One is plus 30 minus 20. So with respect to reference, voltage is plus 30. Plus 30 means anti-clock. Voltage is plus 30 anti-clock. Current is minus 20 clock. Current is minus 20 clock. So what is the phase difference? 50 degrees. It is 50 degrees. Yes or no? It is 50 degrees. Okay? Then the electric iron is rated for 230 volts, 400 watt. The voltage rating is 230 referred to as. See, normally in AC 230 means RMS value. RMS value. Yes, working value or meter value, RMS value. 230 is what value? RMS value in our system. Then a geyser is operated from 230 volts, 50 cycles. The frequency of instantaneous power. Frequency of instantaneous. See, if you plot in a resistor, voltage and current are in phase. Geyser is a resistor, na? Geyser is a resistive load. So this is voltage across resistor. Okay, this is the current through resistor. Because both are in phase. Current through resistor. Now power is what? Power is product of voltage and current. So Vm sin omega t into Im sin omega t is Vm Im sin square omega t. Vm Im sin square omega t. Because positive into positive positive, negative into negative positive. So this is power function. This is power. So power frequency is double the supply frequency. Power frequency, instantaneous power frequency is double the supply. Supply is 50 cycles. So instantaneous power will be 100 cycles per second. 100 cycles per second. Because he is asking instantaneous power. Be careful, sir. Not power system frequency. Instantaneous power is double. Now here again, sir, see the voltage across RL, CR, 3, 14, 10. The voltage across sinusoidal RMS. What is the total? Again, it is phasor sum, na? Because it is a sinusoidal supply. Phasor sum of VR, VL, VC is V, not algebraic sum. Previously, you remember, this was parallel circuit. KCL is phasor sum of current. This is series circuit, phasor sum of voltages. Chalo. Now, first of all, here current I will take reference. With respect to current, which voltage is in phase? Resistor voltage, that is 3. Inductor voltage, yes, lead current by 90 because current lag 14. Capacitor voltage lag, this is 10. Now, phasor sum of VR plus VL plus VC is V. This is 14 and 10. So, resultant, this is only going to be, this if you cut, this is 4. So, resultant is 3 plus 4, 5, again 5 volts. It is 5 volts. Phasor sum, not algebraic sum. Okay? Be careful. Don't say I will add and give the answer. Chalo. The reactance of 1 farad capacitor when connected to DC circuit. See, for DC, capacitor acts as open. So, reactance is infinity because XC is 1 by omega C. Okay? Yes. Omega is 0 for 1 something by 0 is infinity. So, reactance become infinity, open circuit. Open circuit. The average power in a pure inductor. In a pure inductor, average power is 0 because how much it stores, that much it releases. Because, yes, same way in inductor, if I take voltage, but current lags by 90. Current lags by 90 in a pure inductor. Current lags by 90. Current lags by 90. Okay, 90. This is 90. Then power. Positive voltage, negative current, negative power. This is positive. This is negative. This is positive. So, average will be 0. Average will be 0. Very interesting bit. Now, the RMS of periodic waveform. Chalo, if you look at the RMS of this periodic waveform, the time period is T. Let us define the function for one full time period. First from 0 to T by 2, it is like y equal to minus mx, S or no slope. So, this region, it is again directly root of 1 by T integral 0 to T by 2 function square. But what is the function? It is like minus. So, slope is opposite minus 6 by T by 2, minus 12 by T. Okay, minus 12 by T, T square dt. dt, okay, plus, this is directly plus integral T by 2 to T 6 square dt. So, this is simple. If you observe root of, this is 1 by T. If you observe there, this is 144, okay, by this is nothing but T square into this is T cube by 3. T cube by 3 means 1 by 3 and T cube if I substitute there T by 2, this is going to be how much? Yes, that is T cube by 8, okay, and this however plus 36 into T by 2, 36 into T by 2. So, if you remove this T and T, that is root of, okay, if you observe here 3 times if you go, it is 50 minus 2, 48, 48 by 8, 6, okay, and then plus it is 18. So, this if you do, you will get something 2 root 6, okay. Yes, 6 and 18 root 26 is 2 root 6. Okay, very simple calculation, but no calculator is required because you know this function is a negative ramp without intercept, like y equal to minus mx. This is however constant. Okay, so such bits are given where calculators are not allowed, but you have to be very accurate and fast. Lot of practice only is necessary. A circuit having power factor of 0.8 consumes 40 watt. What will be the effective what will reactive power? See, first of all, he gave power factor and active power. From that, let us calculate S. S is equal to P by cos phi. P is S cos phi. P is how much? 40. Cos phi is how much? 0.8. So this is 400 by 8, 50 VAs, 50 VAs. Then Q is S sin phi, S sin phi. 50 into sin phi. So this is 0.6, that is 30 var, 30 vars. 30 vars, yes, it is 30 vars. Okay, na? It is 30 vars. Now the next module is, yes, simple, DC and AC network theorems are network theorems, okay. Lot of things we did teach, but I will tell you something. See, if this is equivalent to dash, okay. Now source transformation technique, watch this. Now this is 10 by 2, 5 amperes up, 2 in parallel. Here 8 by 2, again 4 amperes up, 2 in parallel. 5 and 4, total 9 ampere up, and 2 to parallel 1. So 9 ampere in parallel to 1 become 9 volts in series to 1. 9 volts in series to 1. Similarly, here you see 6 by 3, 2 ampere up, but 12 by 6, 2 ampere down. 2 ampere up, 2 ampere down, resultant 0. 2 ampere up, 2 ampere down, resultant 0. But 6 in parallel to 3 is 2 ohms. Is 2 ohms. So overall it is 9 volts in series to 3 ohms. It is 9 volts in series to 3 ohms. 9 volts in series to 3 ohms. Okay? That is the meaning. Now see, determine current by using superposition theorem. What is superposition theorem? The effect produced in any element when all sources act time is also equal to sum of individual effects when each source is taken separately. Chalo. First I will take 10 volts open current. Open current, this will be I dash. So I dash is directly 10 by 3. Then second step, I will take current, remove voltage, short it. Second, I will take this current, remove voltage, short it. So let this be I double dash. I double dash is total current into opposite 1 by sum 3. That is 2 by 3. So total current is I dash plus I double dash. So I is 10 by 3 plus 12, 12 by 3. 12 by 3 is 4 amperes. 4 amperes. 12 by 3 is 4 amperes. Okay. Then determine the Thevenin's equivalent. Now Thevenin's will convert any network into voltage source in series with resistance. Now if you follow Thevenin's resistance, short it. So RTH will be clearly this 15 plus 10 in parallel to 10 5. So 15 plus 5, 20 ohm. And when it comes to VTH open circuit voltage, because this open current cannot flow, both are in series equal. Na? Both are in series equal means this will be 50%. 50% of drop will be 50 volts. So VTH will be 50 volts. Okay. So VTH is 50 volts, RTH is 20 ohms. Okay. VTH is 50 volts, RTH is 20 ohms. That is the meaning. Then for what value of R Pmax occurs in it? We know Pmax occurs in the load when load resistance is source resistance. Load resistance is source resistance. So that is nothing but Thevenin's resistance. But this voltage source, short it. Short it. So if you observe, okay, chalo, I am simplifying with respect to this, okay, let this be A, let this be B, but because you short it, this entire thing is B, this is A, let this be C. So A, B, C, I am doing node shifting. One is A to B 6 ohms, okay, A to B 6 ohms, okay, then B to C 4 ohms, okay, B to C 4 ohms, okay, another B to C 4 ohms, another B to C is also 4 ohms, and finally A to C is 1 ohm. A to C is 1 ohm, and you are looking from AB. So 4, 4 parallel 2, 2 plus 1, 3. 3 is in parallel to 6. 3 is in parallel to 6 is how much? 2 ohms. 2 ohms. All did we did, sir, and these are the relevant exam models only. I did all this we did, okay, all this we did. What is the maximum power transfer to the load if resistance is from 0 to 10 or 1 to 10? Now this time he is varying RS and asking maximum power transfer to the load. Be careful. He is varying RS and asking maximum power. Now here, generally in maximum power we say load resistance is source resistance if you vary load, but here is varying source to maximize power in the load. Ulta problem. So RS minimum will give highest power. RS minimum will give highest power in the load because that will drive more current. So this is different problem because for what value of RS is asking Pmax in RL as RS is varied. So minimum RS is 1 ohm. This should be 1 ohm. Don't say now load resistance is source resistance. That is general statement. But because he is varying source side, minimum source will give highest load power. So in that regard, RS should be minimum. Then what is the load current? Yes, 12 by 3, 4. So I square into RL. So 32 watt is the highest. No other value can give highest. Okay, 32 watts. Now here for what value of RL Pmax occurs? So this is case 2. Load is spurious. So voltage source short. RL should be RTH. So these two in parallel. So if you short and look from here, parallel. So RL should be modulus of these two in parallel. But 6 plus J8, 6 plus J8 parallel is nothing but 3 plus J4, which is root of this is 5 ohms. 5 ohms. 5 ohms. Okay. So yes, I did a lot of things. Now this is one more bit I want to talk. Find the values of V and R. See, find the values of V and R. Now this is in parallel generator form. Parallel generator form. So what is Millman's voltage? Parallel generator form? Yes, sigma V, that is nothing but 10 by 3 plus 10 by 3 plus 10 by 3 by resistance also 1 by 3 plus 1 by 3 plus 1 by 3. That is 10 only. And when it comes to resistance, it is 1 by 3 plus 1 by 3 plus 1 by 3. Okay, sigma 1 by R. It is also 1 ohm. It is 1 ohm. It is 1 ohm. So 10 volt and 1 ohm. Okay, because in parallel generator form, what is this theorem called? Millman's theorem. Okay, then you see now series and parallel resonance we are talking. Yes, series and parallel resonance. See what sort of bits came in resonance. This is another module which is part of AC steady state. A series RLC circuit resonates at 1 megahertz. At 1.1 megahertz, what is the nature of the network? What is the impedance? But you know, in resonance, if you plot reactance versus frequency, it will come like this. At resonance frequency, reactance is 0. For frequency greater than resonance frequency, reactance is positive, net reactance. And for frequency less than resonance frequency, net reactance is negative. So for frequency greater than resonance frequency, net reactance is what? Positive. Net reactance positive means inductive in nature. Inductive. Okay. Then the bandwidth of AC series RLC, bandwidth, we derived now, that is omega 2 minus omega 1 is R by L. R by L. Yes, R by L. Simple. We derived it. Same. Then in a series resonance circuit, the impedance at half power frequencies. See, first of all, impedance is R plus J XL omega L minus omega C. But at half power frequency, this is either plus R or minus R. Either plus R or minus R. If you put that, Z is R plus and minus JR at lower and upper cutoff. So modulus of Z is nothing but root of R square plus R square. That is root 2R. Root 2R. Answer is root 2R. Okay? Answer is root 2R. In a parallel RLC circuit, if the lower cutoff frequency and upper cutoff frequency, what is the bandwidth? Bandwidth is the difference of these two frequencies. Difference. Simple. 2800 minus 2400 is 400 hertz. 400 hertz. Yes. What is the bandwidth in kilohertz in a series RL circuit? Having this. Bandwidth is how much he is asking. Yes. What is the bandwidth of a series RL circuit in resonance? Having this. So how to calculate bandwidth which I know? That is omega 2 minus omega 1. Actually you can say, see, we know quality factor. We know selectivity is nothing but quality factor. But this selectivity is quality factor which is, yes, resonance frequency by bandwidth. So now bandwidth will be, yes, resonance frequency by quality factor, you do that. But what is Q naught? Q naught is 1 by R root L by C. Okay? Yes, from that you go, and F naught is, yes, directly, or you write omega naught, 1 by 2 pi root LC. So what you do, first find these two and substitute to get bandwidth. Okay? That I am leaving to you. Then calculate the value of quality factor in a series RLC. Again, quality factor of series RLC. Yes, I told you now, quality factor is 1 by R root L by C. 1 by R. R is how much? 1 by 30. Root L by C. L is how much? 27 milli by C. C is how much? 0.03 milli. Again, milli cancel. So it is 1 by 30 root. This is nothing but 2700 by 3, 900. Root 900 is again 30. 30 by 31. Quality factor is 1. Quality factor is 1. C 1, option B. Formula base, sir. In a series RLC, Q naught is 1 by R root L by C. Okay. Now magnetic circuits, just let us expose to some bits. Now see this question. In a coupled coils of L1, L2 having mutual inductance M, the relationships among must satisfied. Clearly, M is less than or equal to root L1, L2. Standard bit. Mutual inductance is less than or equal to root L1, L2. The mutual inductance between two closely coupled coils is 1 Henry. The turns of one of the coil is decreased to half and other. So we know M is root L1, L2. And we know inductance is proportional to square of the turns. Chalo. Now what is telling? If the turns of one of the coil is decreased by half. If turns is decreased by half, inductance become by 4. So one inductance become by 4. And the other is doubled. Other coil turns are doubled. Terms are doubled means inductance become 4 times. 4 into L2. So again you remove 4. It is root L1, L2 only. So inductance, mutual inductance is same. 1 Henry only. So mutual inductance between two closely coupled coils is 1 Henry. If turns of one of the coil is decreased by half, inductance become by 4. Other is doubled into 4. By 4 into 4 is same. So same 1 Henry will come. Two inductors of self-inductance of 9 and 25 and mutual inductance between two coils is 12. The coefficient of inductive coupling will be dash. The coefficient of inductive coupling. So he is asking K. But what is K? K is M by root L1, L2. Simple. Now M is how much? Yes, 12 milli. And this root L1, L2. Root 9 milli into 25 milli. That is 12 by 3 into 5. That is 4 by 5, 0.8, 0.8, 0.8. Okay. Then yes, some of the bits I am just going through. Yes, everybody. Now see this question. What will be the coefficient of self-induction if the current changes from -4 to plus 4 to -4 in this? See, current is changing from +4 to -4. +4 to -4. In how much time it seems? In how much time it seems? 0.1 second. Okay. And EMF is 16 volts. Now we know that. Yes, we know that. Yes. E is minus L di by dt, or yeah, that is what you know, or you are decreasing, minus of minus become plus, okay, into L di by dt. Yes or no? L di by dt, or difference. So if you observe how much is the voltage, 16 is equal to L into, okay, is asking the Henry only, L into change in current by change in current. 4 minus of minus 4 is 8. 4 minus of minus 4, change is total 8 by delta, this is 0.1. So L is nothing but, yes, L is nothing but if you see, yes, this is nothing but if you take here, okay, that is 2, if you take here 2 into 0.1, 0.2 Henry, 0.2 Henry, 0.2, C, option C. Okay, this is like induced EMF, Faraday's law we study now. Two coils are said to be magnetically isolated. Magnetically isolated means not at all coupled. If coefficient of coupling is 0, 0, not at all coupled. Okay, not at all coupled. Then transient, see actually transient, see they are not even transient with L and C, but what sort of bits C gives you see. Now see this question everybody. Determine the time constant when the switch is getting opened. Chalo, when the switch is getting opened, this is where tau is RC, tau is R equivalent to C. What is R equivalent to R? C is this, 2RC. So 2 hours. Switch is opening. If switch is closing, then R equivalent is R in parallel to 2R and then C. But here switch is opening. So this is waste. Tau is RC. Discharging time constant 2RC. Now if resistance of 20 ohms and inductance of 2 Henry, now time constant of RL circuit. This was RC circuit, RC. Time constant of RL circuit is L by R. L by R. L is nothing but 2. R is nothing. 1 by 10. Okay, 1 by 10, 0.1. Now see this question. In the given circuit, find the current in 3 kilo ohm resistance at 2 seconds. See, this is closed at 5, this is opened at 3. This is closed at 5, opened at 3. But at 2 seconds, this is closed now, so 6 by 3K. See, this is closing at 5th second, but this is opening at 3rd second. So until 2 seconds, this will be there, this is open. So at 2 seconds, this is still there. So 6 by 3K, 6 by 3K, 2 milli, 2 milli. So answer is 2 milli, D, option D. Now see this are very interesting. In the circuit shown, how will the voltage V1 and V2 change when the switch is closed? See, initially R1, R2 there. Now switch is closed means there is another resistance coming in parallel. Now in a parallel connection system, resultant is lower than the least. By connecting R3, this will decrease, this will decrease. For the same voltage, if this is decreasing means voltage V1 will decrease, V2 automatically will increase. Initially R1, R2. By connecting another resistor in parallel, resistance in parallel, resultant is lower than the least. So this will decrease. But in resistor, voltage division is proportional to resistance. If this is decreasing, voltage will decrease. For the same voltage, if this is decreasing, means this will increase. So V1 decreases, V2 increases. V1 decreases, V2 increases. That is option. Now, very interesting, sir. If figure lamp show a picture is switched on, from the moment on switch on, how long it takes for the lamp to glow? Current travels at the speed of light. Because originally in EMF in a pure conductor, traveling speed is 5 by 6 C naught. That is the speed in a pure conductor. So current travels almost at the speed of light. In 1 kilometer, nothing, sorry, negligible time. So the moment you turn on, is it taking 3 seconds? No. 1 second? No. 0.1. So the time practically 0 because the velocity of propagation of electric current is almost that of light. D, option D. See how good the question is? D. Okay. This is another question. What is the time constant? Now you cannot lump inductor, capacitors and resistors separately. So you have to go to Laplace. See, if this is Z of S of each branch, Z is R plus 1 by CS, both are in series. But 2 are in parallel now, so Z total of S is Z of S by 2, Z of S by 2. So Z of S by 2 means this is R by 2 plus 1 by S into 2C. So it is like R total is R by 2, C is 2C. okay, because I divided. So tau is RC. R is R by 2, C is 2C. It is RC only, time constant is RC only. When you cannot lump, go to S domain. Laplace domain, where R is R, C is 1 by Cs. So for each branch I got the impedance function, but there are two such impedances in parallel, so overall Z becomes Z by 2. And after writing like Z by 2, this is overall R, this is overall C, tau is RC. Very interesting bit, na? You cannot lump them. Okay, now a transient current is due to, transients occur because of energy storage element, change in stored energy in inductors and capacitors. Okay, not by voltage, not by resistance, not. It is change because inertia elements are reason for transients. An impulse response of RL circuit is what? I naught e power minus t by 2. It is an exponential decay function, decaying exponential function, not rising. Step response rising. Impulse means natural response. Natural response is decaying. Okay, not step, not parabolic. Now here also, sir, a constant voltage 60 volts applied at t equal to 0. What is the current at 0 plus? See, the moment I close, inductor acts as open. So current is also 0, because inductor will not allow sudden change. When switch was open, 0. Switch close immediately also 0, because at 0 plus inductor is open. At infinity short. Now 3-phase circuits, just some sample plates we'll do and we'll close. Like see the standard at least. Okay. Now see here, in a 3-phase system, volt ampere rating is given by root 3 VL IL volt amperes. Root 3 VL IL. Okay. Or 3 V phase I phase in terms of it. Now which of the following is not correct statement in star? So in star, the phase current equal to line current? Yes, in star. Phase voltage is less than line voltage? Correct. System does not control neutral, it contain neutral. But it is a 4-wire system is wrong. A star can be balanced 3-wire system also. So having a compulsory 4-wire system is wrong, because star can be even 3-wire in a balanced system. The line current of a balanced delta connected system 10, then calculate value of phase current. So in a delta, line current is root 3 times phase current. So phase current is line current by root 3. So this is 10 by root 3. 10 by root 3 is less than 10, and you will get this as 5.77. Only one option. A 3-phase balanced condition, each phase has same value of S, impedance, resistance, power factor, all options. Balanced load means all options. Okay. Which of the following conditions is true for a balanced delta network? For a balanced delta network, all. Okay. Just balanced star connection. R1 equal to R2 equal to Ry. Not that this is this. These are all unbalanced. All must be equal. 3 resistors, each one with resistance 27 ohm are connected in delta. If delta to star conversion, each resistance become by 3. 27 by 3 is how much? 9 ohms. 9 ohms. Okay. Chalo, with this, I just gave, see, the intention of this session is to encourage you and give you confidence to understand what level we have learned and what sort of bits have come. First strategy preparation we discussed 2 days back, and this is the level of problems. Most of the bits, 99% of the bits are like this. Maybe 1 or 2% are more challenging, where extensive calculations are required. But a good student can easily even go through them with all the content and detail. Our standard is much higher. So if you learn the standard what we gave in our video, recorded video, these are nothing, sir. And you see what sort of, even much lower than Genco Transco level. So it is a great opportunity for all the students to get such good government jobs in railways and short circuit commission, RRB also, and SSC JE, same style, same pattern. Standard is also equal. So I suggest please subscribe and ask your friends, and don't give up in life. Okay. See, do consistent, okay, with lot of patience, preparation. Success will take its own time, but whatever time available, utilize positively. Don't worry about the competition. Focus on your subjects and the content what we gave, and the standard is very easy. If you put your effort, you should get. And all the best, and I hope most of my students do qualify and become successful in their career, and you should get such good government job. Thank you.